I'll try to speed it up a bit, but I won't promise that we'll finish on time, because we're still behind. As you probably can see, the title of the presentation is a bit different than you have in your booklets. And the reason for that is because there's too much overlap between the last couple of tracks. I'm going to change to a slightly different topic. I'm going to talk about the topic of metrics. Okay? One of the things that one of the topics that we talked about in the panel session this morning was sharing experiences and learning from mistakes, hopefully mistakes of others. Now today I'm going to show a couple of my own mistakes that hope you can enjoy and you can learn from. And my intention is actually trying to interact with you. Okay? So those of you who think, okay, now I can sit and relax, put my feet up, and have sleep a quick power nap, you'll be disappointed. I'll ask for interaction and please play along. So, let me start with a small exercise first. You should all have gotten one pager with this exercise, looking like this. Basically, I would ask you to put a mark in this matrix indicating two things. One is your professional skills, another one is your social skills. Okay? You only need one mark. You can do it anonymously. I'm not holding it against you, but please be honest. Please do it now. Okay? Is it clear what you need to do? Anyone finding difficulties doing the exercise? Okay? Got 10 seconds to complete. Okay, are you done? Still need some time? Difficult, okay. You only need one mark, okay? You still with me? Okay, then let's park it for now, okay? I'll get back to this exercise later. Okay. So, what we're going to talk about today is first about measurement in general. What are metrics, what it's all about, the rationale for metrics, why we do metrics, the kind of effect it will have on people when you apply measurements, what will happen when you try to use metrics to either reward or punish people, and the so-called motivational metrics. Let me start with a definition. What's a metric? A metric is a result of a measurement activity, and this is defined by Fenton and Krieger as the process by which numbers or symbols are assigned to attributes of entities in the real world in such a way to describe it according to clearly defined rules. Okay? So let's take, for example, the unit of a meter, which is a length unit of measure. Someone back in the 17th century said, this is a meter. And someone then said, okay, this length, we're going to use a wooden bar, and to be able to measure against this length, this would be a measure of units, and we're going to use that as the basis for further measurements. Later we converted that into a bar of platinum, because we found out that it's better than wood. Nowadays we're using a measure of the distance traveled by light unit according to an interval of time that is well defined. Okay. What we try to do often in software development and testing is to apply this process of measurement in software and in testing. So what are the typical things that you measure in testing? Anyone? You, sir. You measure something in testing? Anyone? Anwar? Number of hours spent. It's a good measure. Any other measures you make? Number of bugs. You want to measure any bugs? Yes, no? Not sure? Are you counting the bugs you're finding? Yes. Okay. And how are you using the bugs measures? Not all bugs are equal. Okay. But you're still counting them, yeah? Keeping track of them. You probably have a system for that. You keep track of open bugs, closed bugs. how many bugs are still pending, how many bugs are being resolved, and so on. Now this is an example of a unit that we've taken and we try to measure, and on the basis of that, we try to extract information that is useful for us to make decisions. So what do we measure? Let me ask you. You said you're capturing counting bugs. Why are you counting bugs? To make a comparison between releases. Excellent. Anyone else measuring bugs? Counting bugs? Using quality sensor, gyro, reporting defects? Okay, excellent. So actually, you're looking at how fast you're either discovering or closing the defects. Now basically, we use measurements for different things. We use measurements to understand. Through testing, we gain understanding of the processes, of the state of the system, of the quality of the system, and we use this information to make some actions. We also use measurements to assess. For example, how we're doing according to our plans. We use measurements to predict. For example, knowing that only 40% of the planned tests have been executed, will you still be able to make it on time? Well, maybe I can extrapolate and find out whether this is possible or not. Okay? So you use metrics, try to predict, knowing the past, try to extrapolate the future, and on the basis of that, try to make some predictions. You also use metrics to improve. Typically, you want to make an improvement experiment, to try to establish a baseline. Then, you do some changes, some actions. You measure once again, and you compare against the baseline. Hopefully, you've moved in the right direction, and you've made some improvement. So measurement is also the basis for improvement. Last but not least, you use metrics to communicate. Metrics are extremely effective in communicating. You can depict them graphically, visually, and it can help you convey a message and share with the team. What are you measuring? I discussed earlier that the fact that you need to agree on a measure of units. For example, saying this bar is equivalent of 1 meter, and then use that as a basis for measurement. But in testing, are our measures of units, are they well defined? Are unit measures well defined? Maybe, maybe not. I'll get back to this point in a while. My point is, if you don't have a well-defined process, how will you know if you're measuring the right things? You know, there's an old state saying that if you try to measure chaos, if you're not trying to automate chaos, the only thing you get is faster chaos. Okay? How about measuring chaos? What will you get? I guess it could be a random number. So process maturity is a prerequisite for having solid metrics. My wife is a nurse, and when I was working on this slide, she told me that, wow, actually, these are the same phases that a patient would go through. Basically, you know, when they in intensive care, if you get a patient, they go to the stage of shock, which is, you know, denial, reaction, acceptance, and dependency. So the first time we try to introduce a change, they'll go to this, oh, this cannot be happening. Then they'll start to react. At one point, they start accepting the change and using the change in their daily lives. And at the end, they become dependent on it. Introducing different metrics is no different. Especially introducing a metric program, you go through these phases. So how can we distort a metric? There are various ways of doing it. So, first of all, the environment in which the measurement is taking place can obviously have a thing to do with can distort the metric itself. The measurement, I think, you know, in physics, it's if you take, for example, if you want to measure the temperature of the water and you insert a thermometer into the water, then you know that the existence of the thermometer in the water might change the temperature of the water, so it might affect the measurement itself. Another way of distorting the metric is by the team being measured or the team that is measuring? We'll get back to this in a while. So, let's do a small exercise. How many F's do we have here? Anyone? Three, okay. Any hybrid? Six. Five? Come on, guys. 3, 5, 6. 6, okay. Anyone only see 3? 6, okay. Should be easy. How many of you are still only seeing 3? Okay. Let me reveal 6 actually. So, which one did you miss? Why? Because first of all, the sound is a bit different, it's more of a V, yes. And the importance of the word is less than the F within the word. This is an example of a cognitive bias that you have in your mind. So what's a bias first? A bias is a subconscious set of filters formed to our beliefs and experiences. We all, like it or not, have our set of beliefs that will affect our decisions. Actually, most of us would create an impression of another person within the first 10 to 20 seconds of meeting that person. Now, I'm stepping here on the stage. I know that most of you, based on my looks, my height, my voice, have already made an impression about my characteristics and myself as a person, based on your, cultural beliefs, your religious and social beliefs. Now, there's a discussion among scientists whether cognitive biases are actually defects in your brain, whether they are features. It's like a kind of discussion you have between developers. Some say that these are there to help us make quick decisions, while others say that it can sometimes have some unintended consequences. Let me show another one. Show another one that might be interesting for you as a tester. I'm going to play a game. I'm going to show you a triple here on the screen. 2, 4, 6. Now, there's a rule that this triple complies to. What I want you to do is generate your own triples, and if you want to guess a rule, then you can try to guess it. So anyone? I'll put the guesses here. What I'll do is I'll share with you whether your guess complies with my rule, your triple will comply with my rule. Any guesses? Ma'am, couple of guesses? How about a couple of guesses? Okay, let me. There's a rule that binds these 3 numbers. Okay? Now what I want you to do is just to guess a triple that would comply to that rule that you think it is.
4, 6, 10.
4, 6, 10. I can say that this does comply to the rule by these 3 numbers. Any other guesses? Want to make a guess?
First 2 applications.
First 2 applications? No, that's not the rule. Okay. Another guess?
357.
357. It does comply to my rule. You want to get the rule?
Skip a number.
Yeah, you just plus 2 plus 2?
Yeah.
I think that was the same rule.
No, skip. 4, 3, 4, skip. 5, 6, skip.
Okay, you're skipping one number. Okay. I mean, that's a good guess, but it's not my rule. Anyone want to make another guess? free to make guesses. Wanna try? Anyone wanna try? Just shout out the numbers. You, sir? Make a guess. It's free to make a guess. Yes, sir. 135. And what is the rule? You know, not even know? No, that's not my rule, but it's a good guess. Anyone else?
Either all even or all odd.
So you want to make a guess? Triple?
No, I'm telling the rule.
Okay. The rule is all even. No, that's not my rule. That's a good guess.
All even or all odd.
Four guesses?
3, 2, 1.
3, 2, 1. Well, this actually doesn't comply with the rule that I have in mind. Now, what is happening here, I'll reveal the answer. It's quite simple, actually. But what is happening there, you're falling into the confirmation bias. What do I mean by that? Now, in your minds, in your heads, you have already a rule, and you're trying to prove that rule. And the numbers that you're specifying here will comply to your rule. Now, my rule is just any ascending string number. Okay, it's quite easy. Now, this also happens in software development and testing. When a developer wants to test, he will be falling into the confirmation bias. He wants to confirm that the design that he made is successful. So he'll be looking for a positive test that can be done in order to prove that he's right. Now, the guess I got from the gentleman here was the first one that he actually tried to see whether it doesn't comply with the rule. I'll get back to this in a while. I'm building up. Okay. So what's a cognitive bias? Cognitive bias is basically a blind spot that we have in our mind. It's something, a shortcut, result of shortcuts or habits that we have that will affect our decision making. Sometimes it can lead to irrational or less productive choices. And there are loads of different biases that we can fall into. I mean, the list, I think, if you look at Wikipedia, you'll have probably a list of 50 different biases. And scientists are still discovering more and more biases. I've read once that, for example, when you drive in the fog, obviously you know that the likelihood of accidents happening is higher. You know why? Some scientists have found out that typically when you drive and it's foggy, people tend to drive a bit slower because they know that it's foggy. But what happens is that when they see a car in front of them, it tends to be blurry, not very clear, and your mind tends to then misinterpret the distance, which is why accidents happen when it's foggy. So another blind spot that we have, cognitive bias. Another one is probably seen that. Which are the dots? The boxes on the right or on the left? Who thinks it's the boxes on the right? The one? Who thinks it's the one on the left? It's actually the same. Even though if you look, you might look at the ones on the right, so a bit slightly darker than the one on the left. Okay. So let's look at some of the sociological factors that will affect measurements. Now the first one, I'll not go through all of them here in detail, but the first one is quite famous. It's called the Hawthorne effect. It goes back to the 30s, I think, in the US, where there was a factory, a power plant actually, where they conducted an experiment. They wanted to increase productivity, so they conducted a survey, an internal survey, where they basically interviewed all the people in the production line and asked them, what will make you be more productive? What is bothering you? Can we change something? And most of the workers said that actually the light is too dim, so if you can increase the intensity of the light, it make it more productive. So based on this, they decided to actually basically turn on the light, yeah, to make it more the intensity of the light. What happened? Productivity went up by 10%, which is good. They did a couple of other experiments, but at some point actually they went back and asked, the workers for another round of improvements. And some of the workers said, well, the lights are too bright actually. Can you please maybe dim the lights a bit? And what they did was, they lowered it back to the original intensity. That's what do you think happened?
Productivity went up. Productivity went up.
Productivity went up. Why? Yeah, that's correct. It went up actually. Why did it go up?
Because their suggestion was adopted.
Because?
Their suggestion was adopted.
Actually, there was no correlation between the light intensity and the productivity. One of the things that we were discussing before with Mark was actually whether we have factors that are correlated or not. But what was happening is that people felt happy that they were being asked, they were being happy that they were being involved in the process, so the productivity was more a result of being involved in the process, and not as a result of the activity itself, of increasing or decreasing the light intensity. This is actually a classical experiment. Some other experiments you might know of is the placebo effect. That the power of belief. If you believe something will work for you, it will do. Some patients will go into, some patient experience will involve two groups. One will be treated by the real medicine, other will be treated by some medicine with no effect. And sometimes the people being treated with a medicine with no effect will show some improvements. This is called placebo effect. The inverse phenomenon is called the nocebo effect. But basically, when you try to measure something, you might run into some same kind of situation. That just because you're measuring something, you believe that it will improve it. And which is often related to the so-called Rosenthal effect. Once, there was an experiment where a number of teachers were told that certain students in the classroom were either good or bad before entering class for the first time. Now, the funny thing is, they found that there's a correlation between the teacher's perception after a certain period of time that will confirm that what the information that they received initially. So if you've been told that Anwar is a very good student, and then I'll ask, after a certain period of time, say, the teacher, they say, yes, Anwar is a very good student. So the point is, if you as a test manager have certain beliefs that certain individuals in your team are doing good or well, you might end up just confirming your beliefs. Some other examples, in this time I'll go through the details of all the phenomena here. The halo effect is another good example. Basically, when you measure something, especially if you're only measuring one thing, you might tend to believe that this is also applicable to the other areas. Typically, if you have, for example, one team performing very well, you assume that just because they're doing very well in one area, they're doing very well in other areas. Another very, very known one is called the Lake Morgan effect. This is the tendency to overestimate one's achievements when they ask. So, for example, in Denmark, we had one survey about people's driving ability. People just ask how good will they will they assess themselves as drivers. And especially among the males, it was 95% were in the top 5%, which is statistically impossible. So let me get back to the exercise we've done before. This one. Now, how many of you are in the lower box in the left corner? Please, hands up. Okay. How many of you place yourself in the box to the right? Please hands up if you put a mark there. Okay, we have one. How many of you did you place yourself in this quadrant? This one? The upper left corner? Anyone? No? How many of you placed yourself in the upper right corner? Please hands up. Okay, so what I'm saying here is that, I'll say there are a few who didn't answer perhaps, but it looks like 95% of the audience here were in this upper left corner. So basically we have the most social people and the most highly skilled people present in this room. Yes? So I'm very honored to be in your company. And it's a good excellent opportunity to basically to learn from each other and to socialize, because apparently the best people here in the conference are in this room. This is actually a diagram manipulation I've done with you, because no one wants to use the negative numbers yet. No one wants to be on the negative axis. So this is an example of what can happen when I use measurements to evaluate people, to assess people. Okay. So going back to this exercise we done earlier about measuring testing the performance, we all realize that it's an unfair measurement due to various reasons that we've gone through. Point is, we have taken many of these measurements from manufacturing and apply those to testing and software development. Now, if you take a production line in a factory, obviously you have a well-defined input and output. And what we've done over the years is taking the same concept from manufacturing and apply those to testing and development. What's the problem? The main difference is that a production line is about replication. It's the same thing over and over again. Testing is different. You will never run the same test twice unless something has changed. Maybe the environment has changed, maybe the data has changed, maybe the new build has changed, but you will not be running the same test twice. It will be a waste of time. That's one thing. Another thing is, you're not replicating the same test all over across the different areas of your application or in your group. They're having differences. So the point is, when it comes to measuring people's performance, there's a main difference. And if we just take your team and treat them as interchangeable machine parts that can be measured, what will happen is this. After a certain period of time, it becomes unhappy. I hope you enjoyed the graphics. It took me ages to create a rotating face. Okay, so what's my point here? What do you do as a manager, test manager? You have a team. Now there's a guy called Csikszentmihalyi. He investigated a phenomenon called the flow. What's the flow? Flow is typically a state where you lose track of time and space. You're so into what you're doing that sometimes you forget to eat, you forget to sleep, you're very productive. Have you ever experienced the notion of flow? When? Yes? Many times. Doing builds in the middle of the night. A lot of people, let me ask you, have you have a hobby?
Yes.
Have you experienced while doing your hobby that you suddenly lose track of time and you're very productive, very into the zone? This is a phenomenon of flow. A lot of people will experience that after practicing their hobbies in their spare time, but only a few will experience that at work. Now, how do you get into the flow? According to Csikszentmihalyi, it's a combination of two things: skills and challenges. So So basically, depending on the level of skill and challenges you have, you'll be placed in one of these areas here. So if the challenge is low and you have a low level of skills, you'll be in the apathy area. If you know something in this area, you have a low level of challenge, but your skills are okay, you'll be bored. Now, I believe your main metric, your main measure that you should have as a manager is finding out for each one of your team where they start in this metric, in this matrix. Because if you have people here, it means that perhaps the challenge is not high enough. Perhaps you need to move them into a new area. You have to move, if you're doing, for example, functional testing, perhaps it's time to move into automation. If you have people up here, well, maybe it's time to send them to a training course. A lot of challenge, but they're not able to cope with it. It creates anxiety. The main thing is trying to balance the skill against the challenge. And for this, I don't need a metric measuring, for example, the number of peaks pounds per hour. I use my observation to let me know where I am here, this matrix.